Hi everyone. So this is a small video to prepare the lecture that you will have on next Thursday, because it will be basically a MATLAB Dynare introduction, and you can access basically directly during the lecture to Dynare, to MATLAB, and then to Dynare using the UDS tool of the UCLouvain. The only problem is that it is sometimes a tool that is relatively complex for new user to use. So I will show you how you can access first to UDS, and next to MATLAB, and next how to set path accordingly such that you can use basically Dynare on UDS. And that will be basically the same thing as you will do on your computer if you will have a MATLAB license, basically. Okay, so we will just do that now in order to prepare the lecture, and I will talk you a bit about what you will do during the lecture. So first of all, you can go to your virtual office. Okay, so you just go to UCLouvain, you tap UCLouvain, you click on My UCL, you can connect with your UCLouvain credential. It's basically where you find your exam grades usually, right? So here you will have, I think you have it automatically. You will have a widget that is called UDS, Universal Desktop Service. That's where we go. If you don't have it, but I think you all have it, you can directly go and personalize your virtual office, add a widget, and here you have basically all the widget from UCLouvain, and you can add directly here the UDS widget. Okay, if you don't have it automatically. So once you have it, you can directly click on that, and after that you will click on Data Generic. That's where you can access basically all the UCLouvain softwares that can be used by the students for the lesson. Okay, so you have to wait a bit, and after you will have to here I connect automatically, but usually you have, of course, to put your mail address, your UCLouvain mail address, and your codes. Okay, that's where we are. So it's basically like a virtual office that you have online, UDS, and you can find some here. You can tap MATLAB and find it directly here. And now it will take a bit of time to start, because UDS is it's very slow MATLAB on a computer, and it's a bit slower on UDS, so it takes a bit of time for the software to start. So my advice is maybe to start it before the professor arrives on Thursday, or at least to launch it before he starts explaining things about MATLAB. Okay, so we will be ready to use it. So that's how you can directly start MATLAB. So basically what you will do in class, you will define a model that was used previously during the lessons, and also probably one that you also covered during the TP session. And what you will do basically is to define it, and after to inject some shocks inside the world you created, and to see a bit what happens to compute the impulse response function of the related to these shocks. Okay, so basically that's how MATLAB looks like. So you can, here that's basically a command Windows. You can also create a script. Yep, by clicking. Okay, it's a bit slow. You have to let it a bit of time to start. But yes, but what you can do there, if you click on New Script, you will have basically a script that you will be able to edit, and that's what you will do with the professor. You will basically here write your script, and once you will have it, you will have to save it. Okay, so that's what you will do for the professor. But now let's start with the basics. Okay, so here you have a command Windows if you are a script. First of all, if you want to use MATLAB, you need basically to go to in the home thing. If you want to use Dynare, that is a package basically for for MATLAB that you usually have to download. Here it's automatically download. You have to set path here in the environment part. Yeah, you have that, and here it is already there, but it's maybe not there if it's not here for you. You will have to add a folder here. Go to the local disk. Go to Dynare 5.4 and to MATLAB here. Okay, and you have to set this folder. Yep. Once you have done that, you close. You don't save it because you don't have the admin rights, so you will not be able to do it anyway. And once you do that now, you can use basically in the command window the Dynare command. Okay, so after Dynare command, you have first to set here, by clicking here, you have to set where you will be working, your working folder. Here, you just do it in the download folder. Yep. And if you have a script that is there, that must be a mod script. You use Dynare and the name of your script. Here it's money.mod. So basically, the money.mod is the flexible price model that we defined with an also rigid price model that we define. And if we execute that, we'll have some output that will be appeared. Okay, so that's what we can do with the Dynare command. So that's basically a model we define. So before explaining, just talking a bit about what is happening, so we can maybe just check what is in this script that we just define. Yep, so here you have basically the script that we just executed. So you have always a first block where you define after the command var all the variables that you use. You see, so here it's output, consumption, but you can call them how you want. But it's clear I think it's more easy when you use the classic letter, the marginal cost, the labor, the lambda that is basically the marginal utility of consumption, the wage, etc., etc. Here the professor like also to directly define the growth rate basically. That is d plus the variable. That is not compulsory for the computation to work, but that can be useful to go a bit further, to have also information, to have information on the change directly. So you can also define exogenous variable here that is typically related to the productivity shock of or the public expense, this kind of thing. And here there is just the me that is defined to indicate whether we are in the flexible price case or the rigid price case. Here some calibrated parameters, so that's some parameter of the model that to which we give some values. So this value can be a bit arbitrary, or they can be related to the literature or to some estimation. And after we put the steady state targets, because we already know the steady states for the model, we already fix them here. And this is a trick also, but I will tell you later after. Sometimes you will notice that we'll put C beta instead of beta. It's just because the alpha, beta, and all the Greek letters functions are actually function in MATLAB. So it will be confusing for the software if you use directly beta. So you will put something before, like a C, for instance. Okay, and here that's what we define finally here in this block is basically. After the steady states target is basically the equilibrium rules in the model. So all the first order condition basically and the equilibrium condition actually in the model. So that's basically, for instance, here we are our not our labor supply. Sorry, that's the yep. Yes, fine. You see the resource constraint, etc. All the important equations that are defining our system, basically. Okay, that's the definition of the model. Oui, small notes. You will see that every line basically is ended by this kind of semicolon. So basically, in MATLAB, you end the line with a semicolon. So if you just go at the line, you do not change in you do not go to another line in MATLAB's view. So you have to end all your line by this semicolon. Okay. after what you here it's still so here it's the same but for the rigid price model. And here you have of course the definition of all the growth rates that is coming. And here you remember at the first TP we are talking that if you set wrong initial value because you are in a saddle path case, we know that we can, if we go at some point, if we start at some point, we can end up in the ruins, basically in the deaths of everyone in the world. Yep, that's what's actually happened to me the first time I ran the mod file. It was about a real business cycle model, and everyone died in my world. That was pretty sad. Here we use a small trick because we already know the steady states of our model. We put the steady states as the initial value. So if we start from the steady state, we are sure that we do not. We go to the steady state and that nothing harmful happens to these people, basically. Okay, so that's just a small trick that we use to be sure that everything is stable in the result. Okay, and here you just ask for some checks, basically, to check if everything went right while letting the model run. Yep. And after you can define some shocks with some standard deviation, etc. Okay, on some variable, exogenous variable. Okay. And after that, this has just codes to get the result of these shocks and to save them, basically. Yep, for the different things. So that's basically what we executed. Okay. Once you will have written a file like that, you have to save it manually. Yep. Just when you save it, so when you save it, do not forget that to put it directly in the name, the mod extension. So you have to write it directly in the mail. It will not automatically be in the different extension. You have the choice to make, okay? Because this is what you have to do, okay? And when you will have done that, you can just execute the script by using the Dynare command that we use at the beginning here, okay? That's what you do, basically. You use this Dynare command and that you can have it, okay? And so basically it will give you, but you will see that more in detail with the professor. These are basically the residuals of all the variables, so the difference at the end the difference basically with the steady states, if I say no mistakes. So basically it should be equal to 0, something very close to 0 for the variable. Here we see that this exactly equal to 0, which makes sense because we started at the steady states. It may be a bit different from 0 if you do not start at the steady state, but it's usually very close. But if it's big, it means that you have some problems that you have to redefine the thing. Okay, and here you have the steady state result, so basically the value of the different variables at the steady states. Yep. Of course, it is equal to 0 for all the growth rates, by definition. Here you have the eigenvalues that basically tell you if there is some problem here. So it is related to the dynamic behavior of the thing, and that show you that this is basically a saddle path in a sense. Okay, so that's all. You have the model summary, etc. The matrix covariance of the shocks, the transition functions that are basically the thing of interest. Yes, still some eigenvalues. That's just for the other model, basically, because here we define two models, one with rigid price and one with flexible price. Okay, the one that we covered in the second TP, basically. Yep. So that's all the output that you have, and after, when you get these results, the professor will show you how you can plot impulse response function, typically using this result, using this transition function, and then you can see the effect of a shock in the different world that you define, and the time that it takes to come back to the steady states, basically. So that's everything for this small preparation for the lecture of Thursday. Yep. So I hope it will be really nice new skills that you will get there, and I wish you the very best for the session, and a Merry Christmas. Bye bye.